All right. I think we'll get started now. So good morning. Good morning. How many of you were at the principals talk yesterday? A lot of you. So you already know all my jokes, so I can't repeat them. Well, for those who didn't hear the joke, I'll repeat it because I thought they were good. I want to thank you for inviting me to Amsterdam to spend some time to talk to you about a number of subjects during TechEd this year. And I'm kind of your archetypal American in terms of understanding geography because, one, I didn't know that Amsterdam was in Holland. Two, I didn't know that Holland was part of the Netherlands. But you have to understand, especially for me as a Texan, I consider international travel going to Arkansas. So, you know, I'm really testing my limits here. So today we're going to talk about private cloud security architecture. So it's common for all the architecture talks. It's more about thinking about possibilities and considerations, some things that you might not have thought about before or need to think about in a little different way. We won't be going into the bits and bytes. I'm going to avoid talking about products as much as possible, though I may talk about products a little bit towards the end of the talk. This is listed as a 300-level talk, and I'm not sure why it was listed that way. I think because some people might consider this to be 300 level because they're not used to thinking in terms of architecture and architectural constructs and reference models and reference architectures and things like that. If you are an experienced IT architect, then I don't know if you would consider this a 300 level. I don't have any demos. I had a demo for my first talk this morning that was really going to be fantastic, but the internet went down and it turned into a slideshow. So we won't be disappointed regarding demos in this talk. We're calling this a solution for private cloud security. I would say it's an overview for a solution for private cloud security because the actual solution, which I'll present to you, consists of a 3-document set that we consider a solution. So this will be an overview for the solution for private cloud security document set and cover some of the high-level considerations that we discussed in those documents. Who's an IT architect in the room? Okay, so we got a lot of architects here. I'm going to spend just a little bit of time on my architecture spiel for those of you who aren't architects, and then get into cloud and security, general cloud and security considerations, not specific to private cloud. Subsequently, we'll talk about some of the key security differences that we find in the private cloud. We'll talk about private cloud security principles, what we consider principles at this time. Our private cloud security principles are evolving, and I'm sure if I deliver this session next year, they'll be quite different than what you see today. Then we'll talk about cloud security challenges as secondary to the essential characteristics of cloud computing. So we'll take a look at security considerations as a map to the 5 essential characteristics of any cloud infrastructure, whether public, private, hybrid, or community cloud. Then we'll take a look at our current private cloud reference model, and then we'll look at the private cloud security model and how that maps to the private cloud reference model. We're going to go from the old client-server computing world to an Outlook world because really we're going to end up rebooting the data center by adopting cloud technologies and cloud principles, concepts, and patterns. And so we really need to start with a strong architectural foundation to do that. So first, who needs an architect? I spent 16 years in IT without meeting an architect. I didn't know what an architect was. I thought an architect was someone that designed homes. But apparently there are IT architects all over the place, and they provide quite a bit of value, especially as we're going through paradigm shifts like cloud computing. First thing I thought is, okay, in my new team, they expected me to grow as an architect. And I said, okay, what's in it for me? And so they pointed me to this study. They pointed me to a lot of things. Among those things was a study by the Corporate Executive Board, where a number of CIOs were asked, what category of staff skills do you see, one, that are growing in importance, and two, have difficulty hiring or developing over the next 3 years. And as you can see here, that 63% of these CIOs thought that architecture was growing in importance, and that almost 50% of them had difficulty hiring. So this indicated to me that maybe as I chart my career plan for the next 5 years, that I might need to consider architecture. And then I was pointed to this study by Gartner that said there'll be an increasing emphasis on architecture roles, and that the title cloud architect was bubbling up more frequently in job advertisements and requests for IT staff. I was pointed to another study that said that there may be a reduction of the traditional data center infrastructure and operations force of up to 75% by the year 2015, which I found a bit alarming because I considered myself part of that group, and still do, even though I'm growing into an architect role in the next year or two. Where are those people going to go? Many envisioned that these people that did the racking and stacking, the server maintenance, and the application maintenance will grow their careers as solution architects and work very closely with the business groups and provide more value to their companies, rather than being kind of thought of as cost centers rather than profit enablers. Why do we need an architect? Now, you guys that were here yesterday are not allowed to say what the name of this house is. But for those of you who weren't here, do you recognize this place? No? This is the Winchester Mystery House, and was built by the Winchester family that was famous for the Winchester rifle in the United States in the 1800s. And what is so mysterious about this house? Well, it was under construction for 38 years, had 147 builders and no architects. So what happens when you have no architect? Well, you have 160 rooms, 40 bedrooms, 6 kitchens, 2 basements, and 950 doors. Then you have 65 of those doors going into a blank wall, not too useful. 13 abandoned staircases, and skylights, 24 of them go into floors, so you're not seeing a bunch of sky. No architectural blueprint exists today. And so when you look at this, does it remind you of anything like maybe your own network? There are a lot of reasons why that might be so. Maybe you started with a strong architectural foundation, or maybe you inherited a network that had a strong architectural foundation, but it sort of grew as we moved from SneakerNet to client server to internet, NetBEUI, TCP/IP, to now cloud. And now cloud is going to give us the opportunity to start over. But we don't want things just to grow that way like they did in our traditional data center. We want to be very planful and very thoughtful and think about all the problem domains within the private cloud, or any cloud, not just private cloud, so that we are very mindful and purposeful in the way we do things, and don't just let things happen. Also, I mean, architecture also applies, and I didn't even realize this myself, that a physician doesn't just like put an X on the back of the head here, which would be easy for me, as you can see, and then drill and hope for the best. I mean, a physician has a lot of background in anatomy and physiology, pharmacology, biochem, neuroscience, pathology, microbiology, and a lot more. All this background information actually creates an architectural foundation for physicians, and helps a physician with the definitions and the constraints and the requirements to be successful for a particular procedure. Especially at those key decision points where something might go wrong, you want to make sure that things don't go wrong. They might say, Shinder, you know, what the heck do you know about this stuff? And it's because in a past life I was actually a neurologist. Now, when I was a neurologist, I didn't realize that all this study was creating an architectural foundation for me so I wouldn't kill somebody. In addition, security was important even back then. We had to have security in the operating theater. We had to have security in the office to make sure medical records weren't compromised. We had to have security to make sure someone didn't fall down the stairs. So security was very important for us within the medical business. So for me to kind of move from neurology, but actually I didn't really start off as a security guy when I moved into IT. I was more interested in communications because the nervous system is a communications network, right? So it was very easy for me to move into IT. And I saw a lot more growth in IT, and that's why I switched careers in the mid-1990s. So let's do Yuri Diogenes, and I actually put this presentation together. Yuri Diogenes is a technical writer in the Server and Cloud Division Information Experience Group, but he couldn't make it this time, so I'm going to pick up his piece here. We'll talk about general cloud security concepts. So when we think about general cloud security challenges, this includes private and public cloud, there are a number of things that we need to take into account. First, do we trust a vendor security model? In our own traditional data center, we've come up with a number of standards for security. If we're going to move into a public or a hybrid cloud environment, we have to have a good understanding of what security model the vendor is working with. And this security model has to be explicit, and both sides have to have a common understanding so that these can be put into SLAs so that if something happens, you have specific expectations of the vendor that you're working with. You also need to know if you're going to have support for investigations. If there is some sort of compromise, are you going to have access to logs? Are you going to have access to what kind of users were into the system that it could have affected your services that you're running in the public cloud? Also, in the private cloud environment, as you are the cloud provider, what kind of information are you prepared to give the consumers of your cloud infrastructure? So while you need SLAs, if you're working with public cloud providers, you also need to consider the fact that as the business units consume your cloud infrastructure, as part of your SLA, you're going to have to provide these logs and other information to them, which is interesting because we have a division of responsibility there. It's not up to you anymore as a private cloud provider to do all the work. You will provide the compute, storage, and networking infrastructure, but it's not up to you to secure the services that run on your infrastructure. Now, you may come to some kind of agreement with the consumer of your cloud services saying, you are allowed to do this and this and this, and I may even require you to have certain agents on your workloads, but you may not require that. That's something you have to work out with the consumers. Okay? There's some indirect administration accountability as well. I mean, this goes back to the cloud infrastructure as well as the cloud services that run on the infrastructure. Who is responsible for what? Okay? Are you going to be just responsible for the infrastructure, or are you going to take some responsibility for the workloads? In a private cloud, you still have to be concerned about internal threats, and internal threats are actually even more important than they are in a traditional data center. And the reason why I say that is because these tenants in your private cloud or even public cloud are all sharing a collection of pooled resources. If any of the tenants is able to break out of their isolation container within the private cloud and affect the capabilities of the cloud infrastructure, you have potentially cataclysmic results because it's going to take down everything that's running in the entire infrastructure. So you need to be mindful more than ever of internal threats. You also have to still deal with on-premise security in the private cloud. And the reason why I point this out is because if you read a lot of the industry literature, they'll say, oh, with the cloud, we really don't need to worry about security anymore because they don't really say. But they tend to down-level security concerns for unspecified reasons. But I want to say that you still need to be very diligent about on-premises security even in a private cloud environment. So client security, endpoint security remains very important, and this is why we point out endpoint protection here. Also, there's a sense of loss of physical control, and while this is very well understood and understandable when we're working with public cloud providers because it's like I can't, hug my server anymore, what about the people that, like the Exchange guys, they're used to running their own infrastructure, right? What if they move the Exchange to your private cloud deployment? they're not going to be able to hug their servers anymore, and they won't even have control of the compute, storage, and networking that's driving the Exchange server services that they're providing. So you will have to enter into discussions with them, again, regarding division of responsibilities, and that they're responsible for the service element, but you and your cloud fabric management system is going to be responsible for uptime and availability and capacity. We still have to worry about data leakage, and data leakage speaks to sort of how some of the people that talk about cloud security say, well, we don't need firewalls anymore because the perimeter is too porous now. We don't control the devices anymore, as we'll talk about in a little bit, and a number of other issues that are becoming problematic with cloud computing. So how do we deal with data leakage? Well, we're going to have to push security further and further back. Not that we're going to ignore edge security and other traditional security models, but we're going to have to start thinking about hardening the services that are running in the cloud infrastructure and actually protecting the data itself at rest and on the wire and even while in memory by using things like holographic memory capabilities that hopefully will come out in the near future that IBM's working on. We still need to take a defense in depth approach regardless if it's cloud or traditional infrastructure. In private cloud, public cloud, we're not obviating our understanding of general security principles. We're not reinventing the wheel. Cloud is an evolution of data center networking. It's not reinventing the whole thing. So we still need to be mindful of security awareness training even more because more and more of our users are going to be using unmanaged devices to connect to our cloud resources. In addition, the security awareness training is important to make sure that the tenant services don't get compromised as well. Of course, security policies are critical. We need to be able to set security policies not just understood by us as service providers, formerly the IT group, but have to be understood by the business units, the Exchange guys, SharePoint guys, CRM guys, SQL guys, and all the other ones that are going to run their workloads on our infrastructure. As I said before, we still need to pay a lot of attention to on-premise security. Of course, we have to meet compliance and regulatory requirements. This becomes more complex if we look at hybrid cloud environments because especially with talking with people here at this conference in the EU, is that a lot of you are challenged, want to use the Microsoft public cloud, Windows Azure, but because of data location and compliance issues and regulatory issues, you can't do it because you don't have guarantee on the location of that information at any time. So these, again, are issues you have to deal with. And even in your private cloud, I mean, private cloud means what? It doesn't mean infrastructure as a service. It doesn't mean anything magical. Private cloud is very simple. A private cloud is a cloud infrastructure that provides the 5 essential characteristics of cloud computing and belongs to a single organization. Now, that could be on premises at the headquarters. It could be that private cloud could be on a hoster network. The private cloud can be virtually anywhere as long as it meets those 5 essential characteristics that we'll talk about later and belongs to a single org. Okay? So you still will have compliance issues and data location issues. If you have an office in the UK, an office in Amsterdam, an office in Antwerp, and an office in Redmond, well, some data won't be able to go to Redmond, will it? So that's the kind of thing you have to think about because your private cloud should support the ability to move your workloads to any of the data centers anywhere within your network, but you're going to have to meet these compliance and regulatory requirements. And then you have to make sure the cloud vendor has a security program if you're working with public cloud providers. And also, you need to be able to communicate your security program to the consumers of your private cloud service. Thank you. My clock was going wacky here, so I didn't know how much time where I was. So now let's go over some key security differences or things that maybe have a different focus in the private cloud. Now, like I said, we're not reinventing the security wheel. We don't have to relearn security, but we may need to take a different perspective on some issues in the private cloud. One of those first issues is around security responsibility. In a traditional data center, who is responsible for security in the data center? Well, it was us, right? We didn't split security responsibility with our users. I mean, depending on users for security, it was sort of a fool's paradise in Lubberland. You would never do it. But now things have changed, and an example here is the different security responsibilities based on the cloud service model. And I'm kind of overlaying this on our private cloud reference model, which I'll talk about in more detail towards the end of the talk. So if we look at infrastructure as a service, we can see that the provider, you as a provider of the service, are responsible for the core infrastructure security. So you need to make sure that network, compute, and storage is all secure. But the consumer of your infrastructure as a service is responsible for security at the platform level as well as the software level. So you have to come to an agreement with your consumers regarding how they're going to secure their services at platform and software. Now, if we look at platform as a service, if you're going to provide platform as a service, say you're going to run an Azure appliance on premises or in your own private cloud, then you are responsible as a provider to provide security at the infrastructure layer and the platform layer. That still leaves security for the software layer up to the consumer of your cloud service. Again, you'll have to come to agreements on how that's going to happen. Now, if you're providing software as a service or a finished service, and people say, well, wait a minute, Tom, I thought private cloud was infrastructure as a service. What are you talking about, software as a service? There's no alignment between the service model and the delivery model. There's no reason why you can't run software as a service in your private cloud. And one could argue that providing exchange services is software as a service running on your private cloud, right? But if you are providing that, then you're owning the infrastructure, the platform, and the software layer, and you're responsible for security at each of the layers. Now, if we look at the security attack types, they're not significantly different than what we see in a traditional data center, but we can start categorizing them a bit differently if we overlay them on top of our private cloud reference model. So we can see the security layer, and you'll notice the security layer here is kind of represented in this red. What we want to say there is that security is a cross-cutting issue across all the other problem domains in the private cloud. So we're baking it into the architectural design. We're not bolting it in or using Band-Aids after we've built the cloud infrastructure. Then we look at issues in security at the management, and this should be management operations, but I kind of conflated the two here. So we have credential theft and elevation of privilege we might consider there. At the infrastructure layer, we have issues we need to deal with, like data tampering and physical access issues. Then at the platform layer, things like buffer overflows and encryption. Then there are specific attacks we need to be concerned about at the software layer, at the client layer and service delivery layer, as well as at the provider layer. So you can see that when we think about how we're going to secure our private cloud infrastructure, we need to think about the potential attack surfaces at each of these layers within our private cloud reference model. And then it makes it easier for us to decide who is going to be responsible for securing each of these layers, because your private cloud team is probably going to be split up among the overall security, management operations security, infrastructure, platform, software, service delivery, client, and provider levels. Helps you think about how you're going to approach securing each of those layers. There's a good paper on what these specific threats are at each layer called Cloud Security Threats and Countermeasures at a Glance. And if you click on that when you download the PowerPoint, you can see those, and that can start getting you to think about the things that you need to protect against at each layer of the stack here, at each of the problem domains. Another issue that's, I would say, significantly different from a traditional data center that's introduced by virtualization is that we have to deal with a shared tenant model. Okay, so, well, hold on, Tom. This is a private cloud. This is not a multi-tenancy. Multi-tenancy is all about public cloud, right? Well, not necessarily so. I mean, you've got HR, you've got dev, you've got financial services, you've got different product groups and a bunch of business groups within your organization who don't necessarily want to share information with each other. So when in a private cloud, their workloads are being run on a shared infrastructure, shared compute, storage, and networking, we essentially have something that's almost equivalent to a public cloud infrastructure where we have tenants that are no longer looking like this. This is a traditional data center model, right, where each business group or each IT group is responsible for messaging, collaboration, database, or financial services has their own, HR has their own, and so forth. Payroll has their own. So each of the infrastructures may be virtualized. They have their own infrastructure for each one. But in a true cloud environment versus a virtualized data center environment, we have something that looks more like this, which is representative of multi-tenancy. So we have to deal with the critical issue of logical separation, because we have to make sure that we're able to isolate each of these workloads from each other so they don't step in each other, so that they don't have access to the information from other tenants that are on the same shared infrastructure. So this requires strong authentication, authorization, and access controls. We have to think, I mean, we already think about AAA anyhow, but we really need to be assiduous on how we approach these issues in a private cloud, because failure can lead to information leakage and potential compromise, maybe inadvertent, but compromise nonetheless. Another thing is, well, virtualization, if you were at the principals talk yesterday, I made a point to say that virtualization is not cloud, but you rarely see any cloud infrastructures without virtualization because it enables so many capabilities to support mobility of workloads. And as we see here, we have automated mobility so that these workloads are going to move around through the private cloud infrastructure based on our fabric management system. And so we have this unlinking of the services from the physical infrastructure. And this poses a particular challenge to security tools that we're currently using. The tools that we're using right now are used to a physical infrastructure in security. And so they're home to specific servers that are in specific locations, that have specific IP addresses, that are in a specific rack at any specific point in time. But these tools are still playing catch-up. And so in order to really get what we need to secure the private cloud, we have to have tools that support virtualization. So they have to integrate with our private cloud fabric. And that means working with our private cloud fabric management, because these workloads are going to move around, and we don't want the security operations or the security software to say something's wrong when it's not, just because a VM moves or has different hardware or software than it was originally provisioned to look like. We also have to have separate interfaces so that we can have role-based access control to the interfaces, because we don't, I mean, traditionally, storage, networking, and compute, the server administrator handled the servers, the storage guy dealt with the SAN, and the networking guy dealt with the switches and routers. Now with all these capabilities being managed from a single console, I won't say a single pane of glass because we're not quite there yet, but many of that from a single console. Like if you've seen System Center Virtual Machine Manager, you can see the storage, networking, and compute all part of that single console, but you don't necessarily want those three teams messing with the stuff that they're not supposed to. So you have to make sure that you have sort of delegation of administration and role-based access control to those interfaces. Also, these interfaces have to be programmable and elastic and provide on-demand services. And what I mean by that is, if there is a security incident that's detected, The security control systems need to be aware that these virtual machines may be located in data centers that are different than where they were when they first detected that VM, and make allowance for that and be able to remediate based on the current state of that workload. Also, we have to support policies governing logical attributes, and what might that be? Well, one of my favorites is network virtualization. Has anybody heard about the network virtualization capabilities in Windows Server 2012? Okay, so that that, those of you who've heard about it, that we can move a virtual machine from our on-premises private cloud to a hosted private cloud without changing the IP address on the workload. Regardless of what the IP addressing situation is at the hoster site, we can preserve our IP addresses. Well, that's great for virtual machine and workload mobility, but it plays havoc with our security control systems, where we expect that network ID 10.10.10.0/24 is in a specific location. And if the security control systems expect that and they don't find it there anymore, all hell can break loose with false positives. We have to make sure our controls can deal with that. Finally, we have to have a system in place where we can deal with workloads that just are not compatible with each other. One group is going to say, my service is never going to run on the same machine as this guy's service. So our security control systems have to make sure that those two things never run on the same server or never share the same networking infrastructure or the same storage infrastructure. So what are the private cloud security principles? This is our first whack at what we consider principles for private cloud security. These are not as mature as These are not as mature as the principles that we put together for private cloud infrastructure, for those that saw the talk yesterday. So any of you who are interested in helping us mature these principles over time, please come up after the talk and share your card with me, and we can work together on these principles together. But this is where we are right now. First, a definition of the principles. So those of you who were at the principles talk yesterday know what our definition of principles are. They provide general rules and guidelines to support the evolution of a secure cloud infrastructure. They're enduring, which means they're going to last for a long time, hopefully, although I just told you these might not last for a long time. But hopefully we'll get to a point where they are enduring. They're seldom amended, so we're not going to change them very frequently. And they inform, give us information, and support the way we secure our private cloud. The principles form a basis on which a secure cloud infrastructure is planned, designed, and created. So we see here what we currently think are the 11 private cloud security principles. So, apply generic security best practices. Well, that seems obvious, so we had to make that a principle. Enforce isolation. We felt that this was a critical principle because the multi-tenancy is baked in to any cloud environment, public, private, hybrid, community. Security is a wrapper. What we mean by that is that security is baked into the architectural design for any private cloud infrastructure, so that your private cloud essentially has a security development life cycle, so that security is equal to all other considerations and is baked through management, infrastructure, platform, software, service delivery, client, and service provider layers. We have to realize that our attackers are most likely going to be authenticated and authorized individuals. And what I mean by that is the consumers of our cloud services are authenticated and authorized to use some component of that infrastructure as consumers of the cloud service. And so they're most likely to be the ones that will be able to take down our cloud infrastructure, in contrast to outsiders in traditional IT. All data locations must be accessible. And what we mean by that is because one of the essential characteristics of cloud computing is broad network access, all data locations whether they be on the public cloud or the private cloud, need to be accessible to users. This is part of the A in confidentiality, integrity, and availability, right, in CIA in security parlance. So we have to make sure they're available from all locations. Use strong cryptography. We're used to that in the traditional data center, so there's nothing new there, so we thought we'd better put that in as a principle. Automate security operations. This feeds into our private cloud principles in general, where automation is critical, because the principle of minimize human involvement means we have to speak to automation. So as part of security operations, we have to make sure we can automate those as much as possible. We need to minimize attack surface. Nothing new with that. Although when we look at minimizing attack surfaces, again, we have to look at all the domains within the private cloud security model. Limit routing. What I mean by that is that there's a potential for a lot of bouncing around within the private cloud infrastructure, where the tenant services may be able to communicate with other tenant services or even with the cloud infrastructure if we're not very thoughtful and planful about how we enable communications between the infrastructure and between the tenants. So we have to make sure that tenants can only reach who they're supposed to reach, and we can use, like, mention a product here, Hyper-V extensible switch port ACLs, for example, we could use to limit the routing, or you could plug in a Cisco 1000V on top of that as well. Audit extensively. Again, that's something that we should already be doing in a traditional data center. And, well, I mean, who doesn't like logging? We always turn on logging. But who looks at the logs? So we don't want to repeat the mistakes we made in the traditional data center with the private cloud, because everybody loves logging and they turn it on and then they forget about it, they never look at it. Logging is not auditing. Auditing is the interpretation and the consumption of those logs that have useful information that's actionable. So as we move to private cloud, yes, we're going to log extensively, but we're going to turn that information, we're going to turn that data into information that's actionable by our automated security processes. And then we also have to have strong GRC, governance, risk management, and compliance. Again, we should be doing that in the traditional data center, but we're going to be even more impacted by auditors and regulatory issues because of the shared tenant model and the fact that we have a pool of resources that these people share. We'll cover some of the significant issues there. So I just want to say that's kind of our first whack at the principles. I expect them to mature significantly, and we are still thinking about them within Microsoft, and any help we can get from the community brain trust would be fantastic. We have this information on the TechNet Wiki, which, if you want to collaborate with us, I would love to, and we'll give you props and put your name up there, and you can be a famous security architect and a thought leader early in the private cloud growth cycle. So now let's talk about cloud security challenges that are secondary or associated with the 5 essential characteristics of cloud computing. Now, the 5th essential characteristic is metered services, and we're not going to map to metered services because it's not entirely clear to us at this point what the salient issues are in terms of security regarding metered services. I actually proposed several things, but I got a beat down on that, so unless I get support from the community, I'm not going to talk about my ideas in public, because this is meant to represent a consensus effort within Microsoft in which I had some input, but definitely not all. So let's first talk about resource pooling. So what's the problem statement here? Here's the problem statement right here is, as a consumer or a tenant of the services offered by a private cloud in my enterprise, I require that application data is secure, that no one else can access it, and that the data is safe if something bad happens. So as we can see here by the wonderful animation I put together, is that everybody wants to look at everybody else's stuff. Some people want to do it. Some people will do it if provided the opportunity, if there's some hole in your isolation routine. So we have to prevent leakage between the tenants. And again, that goes back to what I said earlier. We have to be especially mindful of our AAA. If If we're weak in any area within our AAA, we put ourselves at risk of data leakage. This is also important, too, because it applies to administrators, because we talked about that central console. We have to make sure that administrators within the private cloud have access only to that material for which they are responsible. So that refers to main security issues regarding resource pooling. Now, if we look at on-demand self-service, that's one of the 5 essential characteristics of cloud computing. Our problem statement can be characterized here in this box where it says, as an architect, designer, or operator of a private cloud, how do I control who has access to my private cloud services, and how do I monitor and audit those services? So I have to think about all these issues, especially who has the authority to demand services in the private cloud, who has the authority to go to that self-service portal and ask for services within the private cloud infrastructure. Because that person may not necessarily be the person who is going to provision the resources, and that may not be the same person who has the responsibility for using them, or the person that is responsibility for releasing them. Because releasing on-demand self-service is it speaks to the private cloud principle of reduce or eliminate human intervention. So people can just acquire services as they need without having to go through an administrator. Administrators love self-service. The problem, the especially problematic issue is that we have problems with the release. Okay? I mean, when we talk about provisioning, there could be errors in security provisioning that we have to deal with, and so we have to make sure that we have policies in place to make sure that those people who are going to provision resources in the private cloud don't make errors in the provisioning, and that goes to the automation that we will provide for the private cloud. Now, especially problematic speaks to the release cycle. I mean, we talked about elasticity. Elasticity is one of the key principles in private cloud so that people can acquire resources when they need them. That's fine. That's pulling the rubber band, right? But then we've got to let go of the rubber band and put the stuff back into the shared pool so that we can meet our principle of perception of infinite capacity. So cleanup processes are important because as people release stuff back into the pool, we have to make sure that nothing's left behind, and this can be difficult. So let's say that human resources acquires a piece of the pool, okay, some storage in the pool, okay, and they use it for a while, and it's like, okay, well, we're going to move on because we don't need this anymore, and they release it back in the pool. If you don't clean up those resources afterwards, Dev may ask for subsequent storage resources, and oh my goodness, look at all this fascinating human resources. Now I know what my boss is making and what my colleague is making, and blah, 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 right? So we have to make sure we clean up as we release. Finally, we have to be very explicit with our SLAs, too. So with on-demand self-service, we have to make sure that when they select a small, medium, or large, that we provide them with a service level, not only in terms of compute memory and storage, but also a service level for security. We may actually, as part of our menu, say, well, we can provide you with a high security solution. So what would that be? Well, we'll put your stuff on a separate SAN, maybe it's BitLockered, maybe your network connection will take advantage of SRIOV, and we'll dedicate a NIC to you. But, it's going to cost more to have this higher security SLA. It's all about a service provider's approach. When you talk to your business units, we'll give you a menu of security too, if you like. Rapid elasticity. Problem statement. So I'm concerned that a rogue application, client, or denial of service attack might destabilize a data center by requesting a large amount of resources. And that brings up a good question then, right? How do I reconcile the perception of infinite resources with reality where we actually don't have infinite resources? Because rapid elasticity, if we allow users And Yuri, when he does the talk, talks about devs really love resources, right? Oh, I have infinite resources. I can code my application to just bubble, expand, and use as much memory as possible. And you're giving me a policy-based system where if I need more memory, I'll just grow memory on demand because Windows Server 2012 lets me use all available memory if you let me. Well, so we have to be careful with that because while policy and automation allow us a great deal of flexibility and provide resources on demand and rapid elasticity, it can also create a resource denial of service too. So we have to make sure that while these malicious or inadvertent attempts to take down the system and prevent us from providing that perception of infinite capacity is not challenged. So we have to closely monitor and manage our resources using our fabric management system. And also our security management system too. So our fabric management system needs to be able to speak to our security management systems. And that's something that we're definitely, I think, not used to. We've got our security consoles. We're used to looking at the things that we want to look at. But the problem is that because in contrast to a traditional data center where everything is and it doesn't change and these servers and services are this way and they don't change unless we do it on purpose, the fabric management system will change the characteristics of these services and the underlying infrastructure, and they have to communicate that with the security management systems. And so one solution is a policy-based quota. And we make that part of the self-service portal. Broad network access. Now, some people will say, well, private cloud, what does that have to do with broad network access? I mean, I thought broad network access, the essential characteristic of broad network access is defined by NIST. The U.S. National Institute of Standards and Technology says that, and broad network access is defined as users using any device from any location should be able to obtain services at any time. Well, I thought the point of private cloud is, I didn't want everybody to get to my stuff. But the fact is that you still need your employees. Employees are going to still need remote access. They're still going to use VPN. They're still going to use reverse proxy. They're going to use direct access or some other remote access solution to gain access to services that are running in the private cloud. So this cloud essential characteristic of broad network access is still applicable. We also have the issue, remember we said from any device as part of the essential characteristic of broad network access. So we've got this BYOD situation we have to deal with. How do we assess the device state? Devices have identities now, not just users. Devices have identities. And we have to understand the device state of that device identity. How are we going to do that if we're not managing those devices? There are ways to do it, but we're going to have to think about how we're going to do it and what our requirements are going to be when we architect the private cloud solution. We also need to think about application access control. I'm going to bring in a product here, for example, UAG, the Unified Access Gateway, has the ability to provide granular access control to applications that you publish. So depending on what device you're coming in from or what location that you're coming in from, UAG is able to surface different controls within an application based on the user device and location. It's very unique. Unfortunately, it wasn't used very much, but it was a unique offering, but it's still something that we need to think about whether you use UAG or another product to do it. How are we going to deal with data left on these unmanaged devices? How are we going to destroy confidential information? We're going to have to take that into consideration too. So this is all about the fact that we're dissociating IT from controlling the devices. We're going to have to address that issue from an architectural viewpoint. Finally, the issue of reperimeterization as part of broad network access. Now, this is very sad for me because those that know me know that, well, I started with Windows 2000 when ISA Server came out. Anybody remember the code name for ISA 2000? Any ISA fans here? Yeah, some ISA fans. The code name for ISA 2000, anybody know, was Comet. So when I was testing Comet, it was at the same time that this other product came out called Tahoe. Do you remember codename Tahoe around the year 2000? That was a code name for SharePoint. And I was looking for a way to make my way in the world because I figured, when I was a doctor, said these experts would come to the hospital. And I thought, I want to be that guy. I want to be that guy. I want to be that guy, but in IT instead. And I realized that the guys that made it big in medicine were the ones that looked for the green fields. Well, Comet was new, and Tahoe was new, so I decided, should I go for Comet or Tahoe? What? And I said, Tahoe, that's a crummy web server. I don't care about that. But this Comet thing, this is fantastic. So I became the ISO server guy. I was a green field, took over the space. I didn't take over the space, but got a big name in the space, and had a great career for 10 years. Don't know where the future of ISO TMG is. I know a lot of you have asked me, and I really don't know. It's in flux, but nothing's set in stone yet. So regarding reparameterization, things are changing, especially with private cloud. This reparameterization means we're actually pushing the perimeters back. So, in a traditional data center here, we had the intranet, and here's the data center. Here's some client systems, and they were all in the old trusted network, the old model of trusted versus untrusted, right? And then we had our DMZ, and here we have the internet, right? But things changed. Things like IPv6. IPv6, the vision of IPv6 is the same as the vision of IPv4, but now it will be possible. The vision of IPv4 was that there would be direct host-to-host connectivity for all communications. No NAT devices, maybe firewalls, block dangerous protocols and such, but direct connectivity. And then we have porous borders we have to deal with. Well, I want my application to get in the network. I want this other application to get in the network. And it was problematic. So we kept punching holes in the firewall. It started looking like Swiss cheese or some kind of punch board. And when I say tail chasing here, what I mean by tail chasing was, well, these guys would say, okay, we won't let that application in, or we won't let you get to that website, or we won't let you get to that other website. So, essentially you were closing holes. You have dams in Holland, right? Dams, right? So we were putting fingers in all these holes all the time, and we were chasing our tail trying to protect ourselves. And it turned out the cost-benefit analysis of this approach wasn't so good anymore. So what we're going to do is we're pushing the perimeter back by moving our private cloud infrastructure back here, and then we have a cloud perimeter where there may be its own, what's it called, the Active Directory, help me out here. Read-only domain controllers. All right, very good. And then our internal network is untrusted just like the internet. Okay, so our internal clients are no different than the internet, so that we're pushing the cloud back here and not trusting anybody, so that internal network hosts and internet hosts are created the same. Now, does this mean we don't need firewalls anymore? No, it doesn't. And you may hear that you don't need firewalls anymore, but you still do. Now, that might not be TMG, but the firewall of your choice is going to be needed, but you're going to need to push those firewalls back so that they're fronting the private cloud infrastructure. And the reasons for this is, like I mentioned before, our attackers are authenticated and authorized within the internal network. We have different client types that we have to deal with that are not under our control, and that this provides us the required, at a network level, defense in depth. Now, I'll go into more specific network level defense in depth towards the very end of the talk here. Okay, the private cloud reference model. Okay, reference model. Now, before I started my new trek into architecture, I didn't know what a reference model was. I never used a reference model. I read a lot of books that I thought might be references. But what's a reference model? So as I started my trek about a year ago into architecture, first thing I did was look at what a reference model is. Well, I discovered that a reference model is abstract. So it didn't really talk about any specific things or like a specific technology or a specific approach. It described entities and the relationships between these entities. Okay, so entities such as management and operations, entity like infrastructure, an entity like the platform, an entity like service providers. What's the relationship between those various entities or problem domains? Defines and clarifies a complex problem space like private cloud. I mean, if we were trying to just tackle it as one big hunk, it would be insurmountable. We've got to break it down to make it more understandable, and it's technology agnostic. Because what we're looking for in the reference model is not specific technologies. We need to get there because the technologies are going to solve the problems, but we need to understand what the problems are and what the possible solutions are first, and then we start our research into technologies that can meet those requirements. So what do we use it to do then? Create standards for objects in the model, okay? Standards for security, standards for infrastructure security and platform security, break down the large problem space like private cloud, define the concepts and the relationships between the concepts. In the principles talk yesterday, we talked about the concepts and we saw the relationships between the concepts with each other, the relationships between the concepts and the principles, and the relationships between the concepts and the patterns. Helps us define and create roles and responsibilities because not one group is going to handle everything in the private cloud. So it helps us define who is going to take what role, what piece of the private cloud. And then compare different things. So when we get to software solutions, it helps us compare. We have this set of requirements. We need this set of capabilities. Now let's do the technology mapping to the capabilities required and then the specific software that we're evaluating. So it helps us with our RFPs. So here's a private cloud reference model. And in the private cloud reference model, we break it into security. Like I mentioned before, security is a cross-cutting issue, so it has to be considered at all of the layers. Then we have the management layer, where we have to think of things like financial management, supplier management, fabric management, systems management. Then at the infrastructure layer, we need to consider infrastructure things like power and cooling, electricity, routing, the hypervisor itself, and various pieces of the hardware and the host servers at the compute network and storage level. Then at the platform layer, there are things like load balancing, the operating environment, development environment. Things that we need to consider at the software layer would be line of business applications, utility applications, productivity, and then we have a set of requirements at the service delivery layer. So this is the model that we use, when our architects use when thinking about building cloud infrastructures. Again, this helps us think about what requirements are and mesh those requirements for our customers that maybe have different usages for their private clouds. But it gives us a starting point, helps us organize our thinking. When we speak about security in general, the cross-cutting issues are not that much different than a traditional data center, right? We have to think about identity and access management, which I'll be talking about later this afternoon in the 4 pillars of identity. And if you have a chance to make that, I'm going to say some really interesting things, at least I think interesting and revolutionary, at least in terms of thought among IT, because my background, my undergraduate degree was actually in psychobiology. So I had a lot of psychology training at Berkeley, and then as part of neurology, I had to have a lot of psychiatry training too. So I have different concepts of identity, as well as IT concepts of identity that I think would be interesting for us to talk about during that talk. But we also have to think about data protection and security monitoring, management, the AAA, of course, and RBAC, incident response and forensics. And these have to be baked among management and operations, infrastructure, platform, software, service delivery, and operations. Now, the private cloud security model is where we start actually layering security issues on top of our reference model. So we have cross-cutting security functionality that goes across the entire model. Then we consider security infrastructure, platform, software, service delivery, management, client, and legal and compliance issues, and that's what this looks like here. Okay, so again, we take a look at specific issues within the cross-cutting security functionality that's broken across all the subdomains within the private cloud reference model. And then there are issues here within the management layer that need to be considered. This is just a subset of concerns here I am using for illustrative purposes. I will at the end show you a document set that's about 150 pages where you can dig deeply into what we consider a solution for private cloud security architecture. And then things you need to consider at the infrastructure layer, such as VLANs and fences and lights. At the platform layer, we have to think about encryption. At the software layer, input and data validation. Wish that was done more often. At the service delivery layer, protocol restrictions and firewalls. Then a number of things we need to think about at the client level as well as the provider level. So again, when you are architecting your private clouds, you might not necessarily use our private cloud reference model. I think you might find it helpful, and you'll probably improve on this too, because as we're evolving it, you'll probably evolve yours together with us, and we'll work together to make it more and more informational and helpful in informing your decisions on architecting your private clouds, and then when you try to communicate this to your designers, you'll be more effective. Some people have asked for a technology mapping for private cloud capabilities using the Microsoft Private Cloud Platform, because, I mean, we're still thinking about how to build these private clouds, and we don't have comprehensive information yet. I'll do the mea culpa here. You've seen a lot about cloud computing, probably with the System Center stuff. And you know, that stuff is really good for creating private clouds, and you've probably seen some System Center Virtual Machine Manager stuff that say, I think there's even a button that says Create Cloud, right? It's a cloud sort of, right? But it's not, if we agree, and we don't have to agree, but if we did agree that clouds must instantiate the 5 essential characteristics of cloud computing, we don't have really good guidance yet on how to do it. But we will, hopefully, in the not too distant future, so that you will be able to build an infrastructure that lights up and enables the principles that I shared yesterday on private cloud, so that you will receive the greatest value, the greatest efficiency, and the greatest efficacy that the promise of cloud delivers. Because if the cloud doesn't deliver on these promises, there's no reason to move away from a traditional data center. So Bill Leffler, who is a brilliant guy on my team, put together this great article that does a technology mapping for the Microsoft products in the private cloud, and takes into account some of these issues if you want to start thinking about some mappings. And that's the AKA MS link there, if you want to check it out. Or just do a search for this name. It's in the TechNet Wiki, so you can get it there, print it out, add comments, and you can even edit it if you want. And if we like your edit, we'll accept your edit. So if you want to make it better, you're welcome to do that. Now we'll finish out with a closer look, and we'll get a little bit more techie here, go a little lower level at some of the issues within private cloud security. First, as we said, while virtualization is not required for private cloud, you're going to see virtualization in every cloud, period. So you're going to have to make architectural decisions and design decisions around what hypervisor you're going to want to use. So here's an example of, we'll take a look at Hyper-V here. So when you install Windows before Hyper-V is running, you've got the Windows kernel and the device drivers running in privilege mode or ring 0. Okay? When we install Hyper-V, it installs what we call a microkernel hypervisor. Okay? It provides an isolation boundary between partitions, which we refer to the guest operating systems as partitions, and includes a minimum trusted computing base with no third-party drivers running in privileged mode. In 2008 R2, the code base for the microkernel was around 650K. I don't know if it's changed that much, but I doubt it for 2012. It may be even tighter. Now, when we install Hyper-V, we have the virtualization stack, which includes all the drivers running in user mode, or Ring 3. And we install server core, and the Windows kernel runs in Ring 0 privilege mode, but then the hypervisor runs at this level that we kind of call Ring -1. Yeah, there's no Ring -1, right? But what we're trying to communicate here is that it runs at a higher privilege than the Windows kernel, so that it is the ultimate mediator between the software components and the hardware interfaces. Okay, so it mediates all access to the hypervisor, and with server core we have a much smaller attack surface because we remove all the stuff that we don't need, and it requires about 50% less patching. Now, when we install guest partitions or guest operating systems that run workloads, the applications run in Ring 3, and that each of the applications have their own worker process. So we add some more applications here, and we see that we have more worker processes running in user or unprivileged mode. This makes it possible for the guests not to interfere with each other, and we also have dedicated VM buses. Come on. Whoops, wrong one. VM buses to make sure that the connectivity to the hardware from the various guests don't step over each other either as they're communicating with the hardware. So there is our microkernel hypervisor. Now, there's other ways to approach hypervisor development, and that is to use something called a monolithic hypervisor. And some vendors, I'm not going to say why because this is not a compete. This is architecture, so we're going to try to take the high ground here, right? So other vendors have a monolithic hypervisor, and what happens with them is their whole stack is running in privilege mode, and this includes drivers. The problem with that is you've got third-party device drivers in there that represent a larger code base. It's harder to test all these drivers from a security perspective, and so it increases your attack surface. Now, you don't have to take my word for it. Here's a quote from Linus Torvalds. He says, "The fact is, the absolute last place you want to see drivers is in the hypervisor, not only because the added abstraction layer is inevitably a big performance problem, but because hardware and drivers are by definition buggier than generic code that can be tested." Linus doesn't work for Microsoft, but it may be something to consider when you're making your architectural and design decisions about what hypervisor to adopt. Now, you'll have to find out what type of hypervisor these other vendors use, but I can tell you that Hyper-V uses microkernel and not monolithic. Now, isolation, I said, was very important, and physical network isolation is part of that. So when we're isolating the networks from each other, the main isolation or the main issues with isolation from the network point of view is the infrastructure traffic, which includes the host management network, cluster heartbeat and CSV traffic, and live migration traffic. And we want to make sure that we separate that from the virtual machine traffic, or what we call the tenant network traffic. So we can take advantage of 802.1q VLAN tagging to do this, where we associate each traffic class, infrastructure versus tenant traffic, a different VLAN ID. Then we can enforce this throughout the network fabric, and we can and if we need to allow some kind of communications, we can use firewalls that are external to the virtualized environment to allow inter-VLAN traffic per policy. We can also isolate the host from the guests, which are critical, of course, because we don't want the guests to compromise the host infrastructure, and we also want to isolate the management traffic from the guest traffic, because even though we as a service providers are mostly concerned about them hurting us, they have valid concerns that we might hurt them too. So we want to make sure that we're not having a negative impact on our consumers. We can also do logical network isolation using IPsec and host-based firewalls. to enable us to block all inbound connections to non-essential services so that we can deny guest to host and management systems traffic. And we can also take advantage, if we're going to use group policy, we can set group policy firewall settings to make sure that people communicate only with who they're supposed to. We can also use server and domain isolation, IPsec, so that domain members say that the cloud infrastructure is a member of one domain. The guests are not members of the cloud infrastructure network, so they will never be able to create an IPsec connection because they won't be able to authenticate, protecting you from host, tenant to infrastructure traffic issues. All right, next steps. I said this was an overview of a solution for private cloud security. So where do you find the solution? You find it on the TechNet Wiki and in the TechNet Gallery. And it consists of 3 documents. First is the service blueprint. We also have a service design guide, and we have a service operations guide. And you can find it at this address, aka.ms/ZAAG2. Okay. When you download this presentation, you can just click that. 3 papers, total's about 150 pages, and it digs deep into all the things I talked about today. Also, there's a Windows Server 2012 book that we're giving away free at this conference. If you haven't heard about it yet, if you look for the MCT Lounge on the far end of the conference center, next to the Windows Server IX booth, they have, I heard yesterday, they have like 3,000 books they want to give away. So if you want a free book, it's about 250 pages, and it's a great overview of Windows Server 2012. And that's the book there. It's got 5 chapters to it, and chapter 2 is really good. It's about private cloud foundational technologies, and I wrote some sidebars on that chapter. And Josh Adams, who worked with us on some of the private cloud design patterns, also wrote some stuff too worth reading. Me and Yuri Diogenes are writing a security book for Windows Server 2012. And that book is going to be called Windows Server 2012 Security from Endpoint, Edge of the Network, Firewalls, and Beyond Cloud. We'll cover all of those and how Windows Server 2012 can be used to secure you at each of those layers. And then for more information about private cloud and private cloud security, we have the Private Cloud Solution Hub on TechNet. And we also have the solution for private cloud security in the TechNet Wiki. Some sessions with related content regarding cloud security. I will be delivering this one this afternoon, 4 Pillars of Identity. Let's cross out solution and say discussion for online success. The principles talk I delivered yesterday, and then I'm not sure if this one's delivered yet. Might want to research that one. These resources for TechEd. And then I think that this was, very good, they did this one. So submit your evals online at this address. And I thank you very much. I hope you learned a thing or two, and go forth and prosper. Thanks. Any questions?